Good day and welcome to episode 7 of the PM Blend. I'm Mark Powell, Joe Finksler. Welcome, Joe. Looking dapper today.
Yeah, as well with you too, Mark. You're looking good. Today
we're going to discuss materials, and we're very fortunate to have Tom Finksler with us today. And
Glad to
Tom
be here,
has
Mark. Glad to be here, Mark.
I'm excited to have you. Tom, talk about the experience you had on the standards committee, and kind of what the book there that's sitting on the desk in front of us represents.
The standards committee for the MPIF builds basically, or documents, I suppose is the better word to say, the very common materials used in our industry. And they do that by doing mechanical testing on those materials. So they'll have bars pressed and tested for hardness, density, fatigue, those types of the elongation, all of those physical properties. And with that, they construct the book that basically has all the common materials that the industry tends to deal with.
Okay. And we've been very fortunate here at Atlas to have you, Tom, serve on that committee for, how many years you've been?
Well,
a long time.
I've been associated in some way for probably 25, 30 years. Mm-hmm. Currently, our metallurgist attends those regular meetings now that they have twice a year. So.
Okay. Yeah. Joe, you ever sat on that committee?
No, I've never sat on that committee.
Nor have I. But we're fortunate to have Tom and Rob, our metallurgists, who have been involved.
They want people that are more in tune with those materials than you and I.
Yeah, right. So let's talk about some of the key factors involved when considering different materials when we're looking at a PM part.
Well, some of that is going to depend on what the customer's end needs are. Whether environmentally we have to be concerned about, is there corrosion issues? Is there some particular strength needs that they have? Mm-hmm. So all of that information, and I think we've kind of talked about it in a couple of the previous podcasts, we ask a lot of questions. And those questions are there because we're trying to create the best product we can, best finished part for the customer. And so those questions are there to try to pull out of them. Some of it may be as simple as what material were they thinking of using? Because most customers, though they aren't as familiar with powdered metal, they are familiar with some other either machined material or wrought material. And they quite often, when they come into a design, already have some preconceived idea of what base material they planned on using. And a lot of times then that will drop to us to go, what's our alternative mixes that we would use in those certain applications. So if it's, if you have a mild steel, a 1018, something like that, you may have something as simple as an admixed F008 or FCO208 or something like that. And then if they have something that has to be hardened, then you get into more details about what their wear needs are, what their strengths are. Yeah, really, which properties are the most important to them. And we kind of tailor that material for those applications.
Okay. And then what we also do, heat-treated materials as well, correct?
Right. You can heat treat our materials just as you would, and not just as, but in a similar fashion. Both in our process as well as an external heat treat operation. Mm-hmm. Yeah.
And our material, coming in looks like what? This looks like sand, correct? Looks like what would you call it?
It looks like the picture behind us.
Yeah, it depends on what color sand you're dealing with.
Because I don't think I've ever gone to a beach and seen silver sand before.
Huh?
I've never seen silver sand on a beach.
Yeah. No, I can't say that I have either, and I probably don't want to see silver sand.
I definitely don't go to the beach and see gold-colored sand normally.
Copper colored.
Or coppery colored. Yeah. But yeah, the shape of it is very much like that,
grains of sand.
Yeah, it's like a granule of sugar or sand or something like that. It's about the consistency of it. And it's ragged in shape, like that sand would be as well.
Joe, we like to call it irregular.
Okay.
Generally.
Okay.
In our process.
Okay.
So, Tom, can you provide some examples of materials commonly used in specific applications, like whether it be, I don't know, if we want to talk automotive or what some different applications may be, but do you have some examples?
That's always a hard, that's a very hard job.
I save all the difficult questions for you.
Yeah, I'll say.
Yeah,
I mean,
I'm giving Joe the softballs. I'm throwing.
Wait, in this area, you're definitely giving me the softballs.
Yeah. I don't know that we really have a common. I mean, a lot of spacer type applications will just use a simple maybe iron copper or iron carbon blend. Whereas if we're looking for more wear, we'll use either a external heat treated material type or a sinter hardened type, where we harden that through our furnaces. Type material.
And then you jump to a bearing grade.
Yeah, and because we deal with so many different things, if you're dealing with a bearing grade, we use a lot of bronze or high graphite iron materials now as well. So,
and what about like a stainless steel? What do you?
Stainless steel, generally, we want it with the people that need some sort of corrosion resistance. And again, depends on what their application is. If they need wear, it might be a 400 grade. If it's a strictly corrosion type, they can get away with 300 grades of stainless.
Okay.
They're more corrosion resistant. So.
All right. And I'm guessing, and I think I know the answer to this, but I'll ask it anyway. When choosing these different materials and understanding they need some corrosion protection afterwards, not all coatings or extra processes work with each material. So it's important to select a material that will accept that, whether it be zinc nickel plating or nickel plating or so on. Correct? I mean, is that?
Yeah, we've run into instances where certain materials do not play well with some of the coatings that may go on so we are particular about,
So material selection is important there as well.
Can be, yes.
And also it would come into play if you're dealing with a machining operation. So we would be careful which materials we would pick if they're going to come back or we're going to come back and do a machining operation to a component.
Mm-hmm.
So that comes into play and gets addressed in those circumstances as well.
So, Tom, why don't you talk about the differences between a pre-alloyed powder versus a premix or an admix powder? What are the differences between the two?
Well, an admix powder, you have all your individual constituents. Say it's an iron, copper, graphite blend. Your iron is a separate element. Your copper is, and your graphite that goes into it are all blended together and to make a homogeneous blend of that material.
Okay.
Pre-alloy powder tends to be those individual things such as your iron, maybe your nickel, manganese, are already as the material is made, it's in the pore. So the particles come out
of the stream.
Each with a certain percentage pretty much in each particle.
Okay.
It's about the simplest way I can say that.
Yeah.
I guess.
Okay.
So.
All right. Joe, do you want to get into the testing methods used to validate, the suitability of a certain powder for a specific application?
Well, obviously, the standards have certain mechanical characteristics, but from our standpoint, what the customer needs and how they're going to use it can come into play. So we may have to look at a couple of different powders in order to select the right one for their given application. As we've already kind of alluded to, if we already know what the customer was thinking about, we have a pretty good idea of what those are. But we may have to adjust our density, or we may have to adjust the blend to accommodate, a given wear characteristic, a particular strength that they need, or hardness, or lack thereof. I mean, we talk about that side of things quite often, that a lot of folks think that, when they look at our product that we have, that the hardness on the surface is going to give them a good representation of how it's going to wear. And it actually is liable to wear more aggressively than what they're thinking, because the particle itself is harder than the apparent hardness of the material. So we have to balance those things out when we're talking about guiding a customer to a given blend.
All right. And I know we kind of touched on this last question in episode 5 when we talked about getting, your PM manufacturer involved in the design process early, but prototyping and testing during the design phase, how does that help in selecting the right material?
Well, by giving the customer the opportunity to take what we've picked out, and sometimes that's more than one conversation that we end up having with a customer to finally select a given blend. It gives the customer that opportunity to actually, in real time, test that powder out of a slug that is machined up into the shape they want, or maybe even a portion of the shape they want. They may not have to go the full boat and machine the finished part, but a segment of the part that's a wear area, they may have to do that. Or we may have to press test bars in order to allow them to see what the characteristics are. I mean, there are instances where we've had, a fracturing of a part that in a test that they wanted to do, and rather than make the whole part, you just make a test bar that's similar to the feature they want so that they can do that test in that certain circumstance. So it really is dependent on what the customer's needs are in that case. But that slug or those pucks or those bars help them evaluate that material in those cases.
And Tom, if I recall, we talked about when we do test, if we send a slug to them, we might send a couple different materials to them to test out, correct?
Yeah. And depending on what the customer or what we think the customer might need, we may choose more than one or two materials for them to try to see how it works in a certain application if they're machining parts already.
Mm-hmm. Yeah, I mean, Joe, I'm thinking just of a customer of mine. It's an appliance application where we've gone through several different iterations of materials and I think we're pretty close to being there now on this particular part. But the interaction, not only what that part needed, but how it interacted with the other pieces in the assembly affected the powder we chose.
Right, because as that goes back to what I was referring to earlier, the way it's going to wear against something else is going to be different than a piece of wrought material or a cast material.
Right.
So, and it may also, the advantage of our process is we do have some porosity. We may introduce some lubrication or some sealant into that in order to allow for better wear characteristics. And the customer may not understand that, the dynamics of that, until they actually go through that test. In many cases, because of that added lubrication that we can apply after the part's formed, it actually will perform better than any other machine component or any other process they can do. And in most cases, it's less expensive.
Mm-hmm. Everybody likes less expensive.
Everybody likes less expensive, yes.
All right. Well, thank you for joining us for episode 7 on materials. Listen, our goal here is to provide a fun environment, and hopefully you can gain a couple nuggets from this that you take back. But again, if you have any questions about powdered metal or different material selection, these are your guys right here.
Hey, you have not mentioned in the past couple episodes that they can, join socials or reach out or,
Well,
you're not keeping your end of this deal.
I think you just did, Joe, and I thank you for it. Please do follow our socials. Thank you again.